What's up, mathletes, and welcome to section 6.1. This is your boy, Mr. Bergman here. We're doing operations on functions. So in each of these situations, you want to add, subtract, multiply, or divide the two given functions to find a new function. Let's check out this first situation. Baseball. Coach is ordering T-shirts and jerseys for X number of players. They don't know how many players they've got. Maybe the roster is still kind of unfinished. But we do know that the T-shirts from a local shop cost $7.50 each plus a $35 printing fee. And then you're also going to order jerseys from the online store that cost $18 each with $20 shipping. So basically the T-shirts and the jerseys situation is going to look like this. However many, this is shipping, and this is shipping as well. The printing fee and the shipping fee do not depend on the number of people. What is the total cost function, C of x? So basically what you're going to do is you can add these two functions together. You got the T-shirt function and the jersey function. You got to add them together like this to get 750x plus 35. That's the blue part, and the red part is 18x plus 20. Combining like terms, because you know you can, you got 2550x plus 55, and that's the total cost. It's a lot easier. If you want to know what the total cost is, you can just use this function here as opposed to the individual two. Let's take a look at here, prom and profit. Tickets to a dance are selling for $50 each. The cost for holding the dance are $25 per person for food and $500 for the venue and DJ. So revenue is going to be this 50x. That's just how much money you bring in, and the total cost is C of x, which is 25x plus 500. Profit is going to be, generally, profit is revenue minus cost. So the amount of money you bring in, the amount of money you put in the cash register, minus how much money you have to pay out. That's going to be your profit. So you want a profit function, you just take the two functions and subtract. Revenue minus cost. R of x minus C of x. That's going to be 50x minus 25x plus 500. Before, I don't know if you noticed that I put these in parentheses just to help me kind of organize my thinking, but here, mathematically, the parentheses are absolutely required because you want to subtract 25x plus 500. You need to subtract all of this, the entire function. Because when you get rid of the parentheses, this becomes a minus 500. So anyway, profit is going to be 25x minus 500. You better make sure you sell enough tickets so that you don't have a negative profit. Architecture and area. The rectangular first floor of a school will have classrooms and entrances to the building. The length of the rectangle will have X 25-foot long classrooms and a 25-foot wide entrance, long entrance. The width of the rectangle will have an X 20-foot wide classrooms and a 20-foot entrance. So basically, you've got this rectangle that you don't know how many classrooms you might have, but you know you can fit however many classrooms you have, you 25 times that number of classrooms plus a 20-foot entrance. Width is going to be the same kind of deal, 20x plus 20. So if you want to know what the area is going to be the length times the width. That is this length function times this width function. And if you wanted to remove all the parentheses, you know you got a FOIL, and you get what you see down here. Big idea is that you can add, subtract, multiply, or divide functions, two functions to create a new function. And so here's what the notation is going to look like. I know it's kind of weird, but this when you add them, it's going to look like this. F plus g of x. When you subtract them, f minus g of x. When you multiply, it'll look like this. F times g of x. How about a weird notation is that? This is separating these two parentheses is not multiplication, it's actually function notation. But in between this f and g, that's actually multiplication right here. F times g of x. Weird. Divide f, if you want to divide the functions, f divided by g of x. So, outside of any real-world context, they might just give you, alex.com might give you something like this. You got f of x is equal to 3x plus 1, and g of x is equal to x squared. You've got to combine the two somehow. So if you want to add them, you're adding 3x plus 1 plus x squared, which gives you just simply x squared plus 3x plus 1. Subtracting, you get something like this. As you can see right here, the parentheses are absolutely required. X squared minus all of this. Distributing the subtraction, you make sure you get minus 3x and minus 1 here. Don't forget this second part. You're going to multiply f of x times itself here. You get 3x plus 1 times 3x plus 1 to come up with a new combined function of 9x squared plus 6x plus 1. And here, if you're going to divide, the f function, 3x plus 1, divided by x squared. Now this is going to be true except for all values of x except when x is equal to 0, because you can't, if there's an input of 0, you can't find the output. Before I move on to the next thing, composition of functions, I just wanted to throw out there that my favorite fruit is the mango. So delicious, especially when it's just ripe enough. Oh, wow. I used to have that all the time in Guatemala, and I want you to tell me what your favorite fruit is when you see me in class tomorrow. Composition of functions. All right, let's check this out. What if I wanted to take a certain number of yards and turn it into a certain number of inches? Well, like a yardstick, for example. A yardstick is 1 yard. If I want, I might first turn it into feet by multiplying it by 3. So 1 yard is 3 feet. And then I'd have to turn 3 feet into inches, and I do that by multiplying by 12. I get 36. You can see I could do that again with a field. A football field is 100 yards. Multiply that by 3, you get 300 feet. And multiply that by 12, you get 3,600 inches. Let's say one person, kind of a tall guy, is 2 yards tall. 2 yards translated into inches. Well, first you have to multiply by 3, and then you have to multiply by 12, and you get 72. So the operations that I have to do to go, and you can see I'm actually calling this the f function for feet. If you want to take this f function here is a function that takes yards and turns it into feet. And this I function, I of x, is going to take feet and turn it into inches. And I do that over 2 separate operations. First I multiply by 3, and then I multiply by 12. So if you wanted to combine those into a single function, one function, let's say you just overall wanted to take the number of yards and directly turn it into inches kind of as quickly as possible, you could combine those 2 operations into one operation. It would be just x times 3 times 12, as you can see right here, times 3 times 12. And that would just be 36x. That's a combined function, or the composition of function in this case. And so you can see 1 times 36 is 36, and 2 times 36 is 72, and 100 times 36 is 3600. Let's do that again in another scenario here. If you're not taking chemistry, you might not know that there's actually 3 different scales for a temperature. We all, in the United States, we all basically use Fahrenheit. Scientists like to use Celsius, but chemists actually like to use Kelvin. Kelvin and Celsius are basically the same, they're just 273 degrees off. So the boiling point of water in Kelvin is 373, and if you want to translate to the Celsius, what you got to do is subtract 273. I know it's a weird formula if you haven't taken chemistry, but that's just what it is. And then 100 degrees Celsius, what you have to do to convert it to Fahrenheit is first you have to multiply it by 1.8, and then you have to add 32 to get 212 degrees Fahrenheit. The freezing point of water, it's 273 Kelvin. You subtract 273 and you get 0 degrees Celsius. Multiply by 1.8, and then add 32, and you get 32 degrees Fahrenheit. And in both of these cases, what you basically have to do is first, from the red function, the CF function here, the Celsius function, you subtract 273, and then you multiply by 1.8, and then you add 32. And if you want to combine those into a single function, it would look like this. You notice how the red operations are inside a set of parentheses. That just helps us do them first. So you take whatever input you have in Kelvin, and then first you subtract 273, and then you multiply by 1.8, and then you add 32. So there's 3 different operations in order. First subtract, then multiply, then add. And so if you wanted to combine them into a simplified function, you can. You just distribute the 1.8 and then add 32, and you get this, 1.8x minus 459.4. This single combined function will take it from Kelvin all the way to Fahrenheit in fewer steps. And it's just a simpler way to do things, rather than do these 3 operations. Let's remove the context completely. Let's just generate some random functions. Let's see, the g function is 2x plus 1, and the f function, I'm just making these up, it's 3x minus 1. So if you have an input here, you can put it through the g function and you get an output. Like if the input is 7, 2 times 7 plus 1 is 15. That's the output. The output of the first function becomes the input of the second function. So 15 is now the input, and 3 times 15 minus 1 is 44. And then here, input is 3. 2 times 3 plus 1 is 7. And that's the output of the first function. It becomes the input of the second function, and 3 times 7 minus 1 is 20. In both of these cases, we've got two different operations, and the red operations go first. First you multiply by 2, and then you add 1, and then you multiply by 3 and subtract 1. And if you're going to combine them into a single function that would take from this input 7 all the way to the 44, what you really got to do is make sure the red operations go first. They go inside a set of parentheses, 2x plus 1, and then on the outside you multiply by 3, and then on the outside you subtract 1. Now, all four of these operations can be simplified because all you got to really do is just distribute this to get the 6x plus 3 minus 1, and then you can combine the 3 minus 1 to get 2. So really, if you wanted to go from 7 to 44, all you really had to do was multiply by 6 and add 2. And 7 times 6 is 42, plus 2 is 44. Yeah, it's way simpler, way faster to go from here to here. And then if you want to go from 3 to 20, all you really have to do is multiply by 6 and add 2. 6 times 3 is 18, plus 2 is 20. So that's the simplified version of what we're going to call the composition of functions. Anytime you're taking two functions and combining them into one, that's in a way that links the input and the output together like this, one after the other. That's called a composition of functions. And this inside the parentheses is what we're going to call the inside function. It's the one that goes first. And anything outside the function, we're going to call the outside function. So here's what the notation looks like. Here, welcome to this little circle. It's called composition. It's a little dot. It's a little circle right here. It's not multiplication. Multiplication would be a filled-in dot, but this is kind of a little circle. So this is pronounced f composed in g. You just read it like that, f composed in g of x. And really what that means is you're going to put f on the outside and g on the inside function. Like you see here, g is on the inside, g is on the inside, and then f is on the outside, as you can see. Now, f composed in g is, after a while talking about it with students, like someone just invented fog of x. You could just see f, it's not really the letter O, but they just called it fog of x just it's like a nickname. Informally, they would call it fog of x, and you can too if you want. And this would be gof of x. In the notation, g composed in f of x really just means you're going to put the f function inside the g function. And then like this. So inside function is f of x, outside function of g of x. And it's formally pronounced g composed in f, but really you can call it gof of x if you're just like casually talking about it in conversation. The big idea is that composition of functions combines two functions by taking the output of the inside function right here, like 15, and making it the input of another outside function. Like here, you can see 15 turns into the input, and then you keep on passing it through. Let's practice this a little bit. Let's say Alex.com gives you functions like this. F of x is equal to x plus 4, g of x is equal to 5x plus 2, and h of x is equal to x squared. You can compose these in lots of different ways. Here's fog of x. You can see, so it might give you something like this, fog of x, and then I think the easiest thing to do is just write it how it's really defined. It is defined as f is the outside function, g is the inside function. And so what is the inside function, g of x? Well, it's really just 5x plus 2. I'm getting that from the instructions. Now, here's the hardest part. F of 5x plus 2. On the outside, what you have to write, you have to recognize that x plus 4 is going to be on the outside of a set of parentheses. So we're going to write x plus 4. But we're going to replace, instead of x, we're going to replace with the input function entirely inside a set of parentheses. So I'm writing the f of x function here, but instead of x, I'm going to write the inside function, 5x plus 2, and then plus 4. So you can see this is what it is, and then to simplify it completely, you remove the parentheses and just say it's 5x plus 6. And that's what you can type in if they give that to you. Let's reverse it. This was fog of x, now this is going to be gof of x. That's g composed in f of x. And really, that just means that g is going to be the outside function, f is the inside function, and f is x plus 4. So let's pass x plus 4 in through the g of x function. We're going to write g of x, and instead of the x, we're going to write the new input, which is going to be the f function, x plus 4. That means it's going to be 5 times, no longer x, but x plus 4, and then plus 2. You got to distribute, you got to combine like terms, but you get 5x plus 2 after you simplify. F composed in h of x. So here, f composed in h of x, you get, it really just means f of h of x. H is the inside function, it's x squared. So you can see it's x squared here, and then f of x squared means you write the f function, and instead of writing the x, you write x squared. So this becomes x squared plus 4, and you can just drop the parentheses, you don't really need them mathematically. Let's do this one, hog of x. Hog of x, we got g of x here on the inside and h on the outside. G of x is really just 5x plus 2, you can rewrite it here. And the hard part is this. Putting the h on the outside means you have to write the h of x function, x squared, but instead of x, you replace the x with a 5x plus 2. And now you might be tempted to say that this is going to be just 25x squared and 2 squared over here, but really you have to FOIL it out. You have to remember this is a plus b squared, and so that's a squared here plus 2ab here plus b squared here, and I'll let you figure out what number goes there. Half of x, h composed in f. That means f is the inside function, h is the outside function. And so f, we remember from the instructions, is x plus 4. We put it on the inside. And now you can replace x, you can write the h function. Instead of x, you can replace it with f. And so that'd be x plus 4 squared. And again, this is going to be a plus b squared. The a term is x, the b term is 4. And so when you square it, you get a squared plus 2ab plus b squared. That's x squared plus 8x plus 16. There it is, y'all. I hope you've enjoyed it. Great job making it through, and I'll see you in class. Take care.